left it at home and I've had some issues. So anyway, that being said, we're going to move forward and hopefully we can get through this relatively painlessly. So yesterday we learned about the being able to use the normal distribution and to find it with the chart, okay? And it was given just straight values, so no application whatsoever. So now we're going to learn how to use application. So the first thing you need to do is you need to write this formula down. It's very important, all right? This formula is going to help us find z-scores so that we can calculate probability using what we did before. This is all going to build on itself. So please, if you haven't watched the video from before, or if you're still having trouble with that, please make sure you have a good understanding of that. It will come more naturally the more you use it, but this will add on to what we just did. So to find a z-score, we go the value minus the mean divided by the standard deviation. And then this is just another formula. So whatever value you have minus the mean over the standard deviation. There will be word problems. These numbers will be given to you, fairly easy to find. So let's continue on with the video. So here's an example. It says the average salary for first-year teachers is $27,989. If the distribution is approximately normal with a standard deviation of 3250, what is the probability that a randomly selected first-year teacher makes these salaries? So what we're going to do is we're going to turn these two numbers into z-scores so that we can use the charts we used before. And I don't actually have the chart on the video. I just assume that you have it with you or that you can see it. So so let's look at what we do. We're going to subtract numbers, maybe. I know I wrote on here. Okay. So we're going to go 20,000, which is my value here, right, minus the mean, that's 27,989, divided by the standard deviation, 3250, right, and we put that in a calculator, and we get negative 2.458. So this is one z-score, and then we do it again with the upper boundaries, okay, 30,000 minus 27,989 divided by the standard deviation, which is 3250, and that's going to give me the upper boundary. So we're going to put these in a picture in just a moment. So 0.61. So these are my z-scores. All right. So now I draw my picture, and I have my z-score of negative 2.458 and 0.61, and I want to find the values between them. So if I look on my probability charts, I'm going to add these two areas together once I find them. So here I have the area for this one is 0.4931, and for this one is 0.2291. I add them together, and I get the probability that the average salary is between $20,000 and $30,000 a year is 72%. Okay. Now for B, in a moment. So B. Now I already know what my z-score is for 20,000 because I found it right here. And I want to find out what's less than that. So in this one, remember, I have to go 0.5 minus. I'll try to take this off here so you can see it. Sorry. So I go 0.5 minus 0.4931 because that was my area for that z-score. And I get 0.0069 or 0.69% possible that they make less than $20,000 a year. Okay. All right, now your practice problem. I'm going to pause for a second. I had requests from people to explain the practice problem, so you might want to pause the video, do the practice problem, and then I will explain the answer on the next page. So, all right, here's your solution. They drew the, oh, oops, I went really fast with the solution. Let me back up just a little bit. Okay, so you'll notice that they drew the picture first before they found the z-score. So, which you can do that if you want. Usually I just do the z-scores first. So we're going to find the z-score, 3.5 minus 3.1 divided by the standard deviation, which is 0.5, which gives me a z-score of 0.8. And they draw the new picture over here. I see no reason to draw two pictures. Even if you draw one picture, you can just write underneath it if you want to put both of the numbers on there. So, and the area we're looking for is everything less than that. So we're going to have this is 0.5 minus whatever this is. And I look on the chart and I get, or not minus, I'm sorry. Let me correct myself, plus, okay, we add them together. I do 0.5 plus 0.2881, again from the chart, and I get 0.7881. Okay, moving on. So now, The next thing we're going to do is that what happens if we're given a mean, standard deviation, and we want to find out the x values, okay? This is much harder. This takes a lot more work, but there's a formula here, all right? It says that, and we have the area. That's what we're given. So we're given all the other numbers. We just want to find out what are the limits, what are the values that we could have. So it's the z-score times the standard deviation plus the mean. So if we look at this, it says the average charitable contribution itemized per income tax return in Pennsylvania is $792. Suppose that the distribution of contributions is normal with a standard deviation of $103. Find the limits of the middle 50% of the contributions. So the pictures are important here so that we can see what's going on. So what we're looking for is we want to know what values are going to give us 50% of all of the values that are there. So if we take our normal distribution, split it in half, we're going to have 25% on one side and 25% on the other side. Okay, this is important because now you're going to reverse what you're looking for in the chart. You're not looking for area, you're looking for the z-score. So we're going to be looking for 0.25 in the chart itself and see what z-score it gives us. It's going to work backwards. I apologize for not having the chart up here. It would make this easier to explain. Once we do that, once we look in the chart, we'll be able to get these. So we look for something that's close to 2.50. It's not going to be exact. Okay, you're going to have to do some, deciding. Either above or below. It really doesn't matter. Whichever one's closer. If you can't pick one, usually you'll be close enough. So when I do this 0.25, I get 0.067, which would be this upper limit here, and the lower limit would be negative 0.067. So to find my value, I go 0.67 times the standard deviation, which is right here, 103, plus the mean, which is 792. And I get, I'm going to do both of them before I calculate, sorry. So then I do the negative value as well, negative 0.67 times 103 plus 792. Calculator them both, and I get something. 861 for my upper limit, that's going to be the top here, and 722.99. So my values, middle 50% of contributions is between 722.99 and 861.01. So I could say 723 and 861 would be fine, but those would be the values that the numbers will fall between. Okay, so here is a practice problem. All right, again, you go ahead and pause it, do the problem, and then I'll explain on the next page. So on this one right here, it says, assume that the blood pressure is normally distributed. Okay, and we're looking for the middle 60%. Or no, we don't. What are we looking for? Would help if I had read the problem. Let's go back and look at the problem. Okay. Yeah, the middle 60%. Okay. Okay, so if we're looking for the middle 60%, we're going to have 30% on both sides. So in our chart, we're looking for 0.3, which, if you notice here, the z-score is 0.84. Then I plug it into the formula. 0.84 times 8 plus 120 equals 126.72. Then I do the negative side. Times 8 plus 120 equals 113.8. And that is it. I will see you tomorrow.